linear functions, they are defined by what type of rate of change? Additive? RJ, what do you think about that?
Correct.
You agree as well? Okay. They are defined by an additive rate of change. Meaning we are repeatedly what? Repeatedly adding, which is shown through what? Multiplying, right? That's a big idea that's going to come up later. See, you know these things, CJ. You said you didn't know anything, but you know this. Right? Stop giving up on yourselves. You're more intelligent than you give yourself credit for. So what is that? So the additive rate of change called what? What do we call that additive rate of change?
Slope.
Is that true? Yeah? Now, what symbol do we usually use to indicate slope? What letter?
Why?
What was the first one you said?
D.
Remember, D is that constant difference or common difference, which is equivalent to slope, but it's a little bit different. Right? No. Yeah, X and Y axes, but what did he say earlier? What letter for slope?
M.
After that, M, thank you. Our slope is M. And how do we calculate that slope? Language. There we go, thank you, right? It's not bad language, just need to be more careful and intentional with our language. The word over does not have a mathematical meaning, but if I say, hey, rise divided by run, that indicates the mathematical operation division. That has mathematical meaning. It is a ratio between the rise and the run of that linear function. This repeated blank, addition, is shown as what? Thank you. Now please notice that it is only for an explicit equation. If you ever have a recursive, multiplication is multiplication, right? In a recursive, you show that repeated addition. So what is the slope-intercept form?
Y equals N plus V.
Amity, do you agree or disagree? And if you disagree, why?
I agree.
You agree? CJ, you agree or disagree? Agree? Okay. Zay? You agree as well. Okay, so we're all in agreement on this slope-intercept? Alright, point slope.
Y equals
M times x minus x1 plus y1.
Like that?
The x's are in parentheses.
So the x minus x1's in parentheses? Okay, so I need to fix that. Okay? Thumbs up if you agree. Sounds good. Alright, so y equals m times x minus x1 plus y1. Now I do want to point out and remind you, this x and y with no subscripts, no ones on it, those are the what for the equation. This x and that y, those are the what? So let's remind, so which one is the point? So x1 is not a point, but that is the x value of a point. What is the y value of the point? Y1. See how it's x of 1, y sub 1. The first point is the x value of the first point, the y value of the first point. We all good with that? Okay? So we have our point there. So this x and this y, it's just like this x and this y. What are the x and y? Those are the, not values, there's another V word.
Variables.
There we go, those are variables. Those are the things that can change. Those have values, the values of that point. But the x and the y with nothing else, those are variables, those are things that can change. We all good with that? Okay? So what about standard form? Okay. This is a graphic organizer to help us organize our thoughts on these three different things. Sound good? But please understand, this right here is fundamental to everything else. Always, always, always come back to this fundamental idea. Okay, so intern, what's his name?
Mr. Lippum.
Mr. Lippum. This is why we are supposed to have our name cards out. Trey, Zay. Oh yeah, we made ours again on Friday. You weren't here on Friday, right?
Yeah. I think I live on here. I don't remember that.
I do not have it. I would say. I will give you a chance to make it again at some point, Zay, but we need to make it. Because these are to help Mr. Lipham learn y'all's names while he learns your names. Sound good? No.
Huh?
It's to help him learn your names while you learn his name.
There we go.
That one. That's what I said. Ignore the 30 seconds before that. Okay. So we're going to look at our objectives, and then we're going to work on this graphic organizer in our small groups. Why do we look at objectives every day?
So you have us, bro.
CJ, you go ahead and start, because you started first. What were you saying?
To show you what we're focusing on.
Okay, to show you what you're focusing on. Okay. RJ, what were you saying?
Help us grow.
To help you grow. How are these things going to help you focus on, or to know what you're focusing on? Why is that important? How does that help you grow?
Because you kind of like speaking it into existence. Kind of like.
Kind of. Let me ask you this. Amity, can you read our first objective?
I can determine the best form of a linear equation based on what is being given and asked for within a mathematical problem.
So what's one of the things you should be doing?
Focusing.
What are you focusing on? What are you trying to learn from this? Or what are we trying to do with this objective?
The form of a line equation based on what is given.
What about the form of a linear equation?
Determine the best form.
Alright, determine the best form, because how many different forms are there of the linear equation?
2.
3 that we've studied so far. Point slope, slope-intercept, standard. So one of the things we need to be able to do is determine the best form based on what is being given, but we don't always stay in what is given. Sometimes we have to convert it based on what's being asked for, right? By knowing this, you should be able to focus your attention a little bit more on saying, okay, I need to know when is the point slope best to use, when is the slope-intercept best to use. The objectives help focus your attention on what you're supposed to be learning. Helps you focus, yes, but on what you're supposed to be learning. Make sense? Trey, can you read our second objective?
I can use my graphic organizer to aid in creating linear equations and inequalities and converting to other forms.
So we want to be able to use the graphic organizer to identify the best form to start with and to get to, but we're also going to use it to help us create those linear equations and inequalities and convert to other forms. Okay? Zay, can you read our last objective?
I can graph line no matter the form of the equation.
The equation, right? So not only do we want to create equations, we also want to create graphs, we want to create tables, all those different things. And so we're going to use this graphic organizer to also help us graph the lines based on what information is given us with the different equations. Okay? We all good on that? Before I forget, and this is my bad for not bringing this up earlier, I need you all to look in your notebook right now. I need you to make sure that you have another graphic organizer. So this orange sheet of paper is going to go into your notebook, but I also need you to pay attention to this graphic organizer on the vocabulary. I gave you all this last semester. At the top it says Unit 3, Systems of Equations and Inequalities. Say again? Okay. So this graphic organizer is where your homework's going to come from tonight. So I need to make sure you already have it. So remember, these graphic organizers are designed to help you organize your thoughts, grow and to learn. Alright? And you need to have your unit vocabulary as the third thing within the vocabulary section. You need to have this new graphic organizer as the 17th thing in this note, in the task sheets and homework.
I don't know.
Do you see how I'm starting to run out of room here for task sheets and homeworks? What's that probably mean I'm about to have to do? Erase it. You need to make sure your notebook's in order. If you need to take a picture of this, take a picture of it after class. But go ahead and put your notebook in order so that when we have a notebook check for the next test, you're good to go. Yes, sir. You need a copy of this? Anyone else need a copy? Anybody else? There's all the others, but not that one? Alright. So again, please notice these graphic organizers are designed to help you organize your thoughts, help you get on top of things, make sure you're paying attention and using them. All right. So we already talked through these different things right here. What we're now going to do is we're going to use this graphic organizer to help organize our thoughts about some key elements within these equations. Now, please hear me very clearly on this. I want you to first work on slope-intercept, then I want you to work on point-slope. After that, we're going to do standard if you have time. But I want you to do everything with slope-intercept, everything with point-slope, and then we'll do standard. It was causing students to slow down too much earlier. Now, this first section up here, you need to be indicating what is essential to write the equation. So what do you need to write the slope-intercept equation? How do you identify those things? How do you figure out what they are? You need all those different details. Work with your small group to figure that stuff out. When you get to point slope, you'll do the same thing. Here, when it comes to graphing the line or the boundary line from the format, create your own equation or inequality and then graph it. Explain how you graphed the line. That's the whole thing, right? That's all I'm asking you to do is to create your own example and explain how you graph the line, because that explanation you'll be able to use later to help you graph that line more. And then the last section is on identifying the solutions to the two-variable inequality. When you have a two-variable inequality, what do you end up doing to identify all the solutions to the two-variable inequality? If you were to have y is less than 2/3 x plus 5, you would first graph that boundary line, but then what would you do after you graph your boundary line? You would what?
Inequality?
No, once you graph this boundary line, which I'm going to just make up something close, I'm not going to be exact just because I'm trying to save time. There's my boundary line. What would I now do to identify the solutions to this inequality?
Make an equality out of it.
Say it louder.
Make an equality out of it.
Make an equality out of it. So the equality would be close to this boundary line. I've got my boundary line. Where would my solutions to this inequality be?
Use one of the points.
Okay, what am I trying to find?
Give me the x is true.
Okay, let's say I pick this point. That point makes the inequality true. What would I now do to identify my solutions?
Plug it in. So
I've already plugged it in. I know that point makes the inequality true. What am I going to do now? What I'm telling you is all this stuff, these are solutions down here. What are you going to do to show someone else that they're solutions?
Plug it in.
Thank you. So we plugged it in, and so I haven't actually done it. I'm just saying in general, hey, I plugged it in, it's a solution, right? Say that again though, Trey.
say it in.
Okay, so which direction am I going to shade?
Sure. Huh?
Down.
I mean,
Remember, that's a solution, so I'm shading. You see how that's below the boundary line? So the question I'm asking you here is, how do you know where to shade? Does that make sense? What I'm asking, so I made up a small example. What I'm asking you is, how do you know where to shade? How do you know where the solutions are? Okay, work within your small groups. We got about 25 minutes to knock out all this information, but we will get further faster by talking with each other. Sound good? Cool. Let's knock it out.